There we go. Oh yeah, that's what I'm talking about. I just installed a nice new 0.068 1000 volt capacitor. Let's check that old one. So, fired up good old capacitance bridge. Check that out. It's leaky at just 100 volts. 300. It's horrible. It's supposed to be good to 1,000 volts. And this is crap. So this may be from the 70s. I think the other caps are plastic film. I'm not sure what this is made out of, but it is garbage. I've been having a much better experience with the Hacko when it came to desoldering these smaller parts. Leads were straight, bam bam, part fell out. Also disassembled the high voltage rectifier tower. It's very awkward with it sticking up. This doesn't appear to be meant to come apart, so I did have to do a little bit of work on it. In particular, this bit was pushed down and the ends of this were melted over, which prevented you from, well, getting it all apart. So I'll have to do a little bit of reassembly on that. Also took out the main filter cap. Now the lugs are too fat for the Hacko tip to fit over, so I went in from the side. Came out fairly easily. Did need to use a little bit of desoldering braid in a couple spots, but it came out nicely in the end. No damage to the traces. We'll talk about what we're going to do with this in a moment, but first I want to demonstrate taking out another one of those smaller caps so you can see how it goes when things go well. There aren't too many more I need to replace though. Okay, here's one. This guy's right next to that can. I'm going to check these ratings too, because some of these caps are 50 volts, some are 400. It depends where they're used. And by the way, this cap that failed, tested so badly, this was the boost filter cap. So pretty critical to the operation, and it would certainly have a lot of voltage on it. There's this guy down here. So 380 volts for the circuits that need it. Something else I'm not crazy about with this is that the on-off switch is right opposite the trigger. So I was actually hitting the trigger when I'm turning this thing on and off. Yeah, that's warm. Alright, so that part. It's definitely handy having the solder mask underneath so I can see. So this is C206, one leads there, one leads there. Put this over one of them, and it will fit over these lugs. Leads, I should say. That's one. The other one, there's a couple parts going in here. Okay, it's the one on the outside. It's bent over a little bit. I'm curious why they left the lead so long on a lot of these parts. Alright, there we go. Now, what I did is I slid this over the lead, and once it was down all the way, I did straighten it out using this tool. Probably not the best thing for the nozzle tip, but did it anyways. Oh, there's just a little bit of solder holding it in on the first lug I did. Come on. There we go. Actually, I don't think it was solder. I think it just bent over a little bit. And there we go. 0.018, 200 volts on this guy, so it's weird. Each capsule has a different voltage rating, so I've been double checking them. Now, are they all bad? No. For sure, two of them so far have been bad, and the two larger ones. Oops. Yes, I accidentally hit that trigger all the time. These two guys tested bad. So I figure I might as well just replace all of them while I'm at it. There aren't that many. Most of the caps are ceramic. Those I'm going to leave alone. Okay, what are we going to do about this guy? I want to reuse this to mount that video input output connector to. So I want to restuff this. A few ways to do it. We can cut this open, put new parts inside, and then wrap aluminum tape around it or JB weld it somehow, reattach these. Okay, that's a possibility. This is made with a steel collar here, and then phenolic is mounted on the inside, and the caps are connected to the other side of these lugs. And this outer can is aluminum, and it's knurled over around the outside. So one way I've done it in the past, which is not fun, is to get a thin knife or some other implement and start undoing that crimped, rolled over aluminum and go all the way around, get the insides out, restuff the caps, put it back in, and bend the aluminum back over. A few problems with that. One, it's not easy to do. Two, you start getting stress cracks from work hardening the aluminum. When you're done, it doesn't look all that great because there's going to be some marring around that. So I saw somebody else do something. I haven't tried yet, but it looked cool, which is just file this off. And the aluminum can probably needs some heating because there's usually a tar blob in there, but the can will separate. We can do whatever we need to do and then push it back down. Friction may be enough to hold it in place, maybe just a little bit of glue. So this is phenolic. On the other side, there's usually some kind of rubber or some insulating material. It's maybe that thick. So basically, this whole area is pretty solid on the inside. So anyways, let's see what happens. As far as reusing this, I did test one section. After about 15 minutes, it seemed to form up, but we can do better. The owner wants this to be reliable. This, as we've seen, is not the didn't exactly use the best components in this TV, so let's upgrade everything. Similar for these caps. They're probably some type of plastic cap. Some of them have been testing okay. I'm just replacing them anyways. Well, and here's a fun topic to delve into, is how long do plastic film caps last? Because they don't last for forever. And something I never thought about is, you hear about moisture being the problem with paper caps, and it is to some extent, but also residual acid in the paper I think is a bigger problem. But moisture is also an issue with plastic film caps. Plastic film is hygroscopic, I think is the term. It absorbs water. It absorbs moisture from the air. And eventually, plastic starts degrading, and water doesn't help, and it will start to get leaky over time. Now in that case, because you're not dealing with residual acid in paper, I think sealing them in epoxy is a big help. But nothing lasts forever. But again, how long they last? Probably longer than any of us are going to be around. But eventually they will fail. So I've never done this before, so I'm using some fairly fine files here, trying a few different types. I think I could probably use something a little more aggressive. Power tools, I don't want to damage the underlying steel, so I want to have as much control as I can. I want to stop when there's just a little thin bit of aluminum left. I've tried a bunch of ways of doing this. This is the latest one. They all stink. They're all they're all tedious. Eventually, you gotta get inside this, and there's gonna be, the chemical ooze and tar and just nastiness. You gotta clean all that out too. That's why I don't want to use a Dremel tool or something, because I don't want to remove any extra material if I can avoid it from that steel, or damage any of the leads or anything like that. Yeah, it's good. And I'm going to get a little bit more aggressive file. Yeah, this is going faster, but the problem with being more coarse is it's jumping around. I could put this in a vise, but I don't want to deform the can. I only have to do one of them, so I don't mind taking my time. I've never done it before, I've just seen it done. So I want to get a feel for it. Just doing one final pass with the finest of the files I have out here. Then we're going to start trying to get this off somehow. Let's see. Maybe it would just pop off. Yes. Guess would be the answer. And yeah, there is good. Been a while since I've done this. Yeah, there's always a tab coming from the common negative of all those caps that's like spot welded to the ring. So there we go. Well, we certainly have an intact ring. By the way, it's one reason to save these. If you ever might rebuild one, even if you have something you're not going to rebuild, save them so you can scavenge things like this. Also notice there's some goo under that. I wonder if that's the old capacitor stuff oozing out. It hasn't vented, but it's bulging a little bit. Okay, now comes the fun part. Now I'm going to try heating it. Because this disc, it's going to have a rubber seal around here too, because it's supposed to be, well, ideally airtight. So it's not just going to pull out on its own. Finally. Definitely heating it around here was key. See, it didn't want to come out. There's something trying to heat it up from the other end. There might be a lot of tar in here. Try. There we go. Oh yeah, that's what I'm talking about. Oh yeah, there's a lot of tar down them. There you go. So there was a bit of tar around sealing the end of it, and then a glob at the other end. It's a little juicy. There's some electrolyte left, but that's what kills these usually, as that dries out, and chemically it breaks down over time. So we'll let that cool off and then commence to rebuilding it. Alrighty, it's cooled down now. Let's do a little work on this part of it. I want to dispose of all of this. I could unwrap it, unroll it, but I'm going to try to cut it off. I suppose it'd be easier if I grab the other end. Just don't want to do it with my bare hands. Just using a little mini hacksaw here. Should be all aluminum, so it's real easy to go through. One more. There we go. Dispose of that. And here we go. I'm going to clean this up a little bit. So the goal is to mount 4 new caps in that, such that we can fit the cover back over it. I ordered up some caps special just for this project. Got primo grade stuff, and these values are a little bit larger than I'm used to working with. Like the biggest one is 300 microfarad. I'm used to working more like 22, 47, maybe 82, but not 300. So I guess that'd be this guy. And I went a little bit higher on the voltage ratings. So I got a 330 at 200 to replace the 300 at 175. To go well, the larger the voltage rating you're going to go with, the larger diameter caps are going to be. So yeah, even so, see how big that guy is. So we'll probably have to get creative. I doubt I'll be able to mount them all. Well, I mean, this one takes up almost all the space by itself, so I'll need to stack them vertically and put some extension leads on it. But let's get them all out and see what we got to work with. Might want to put 3 small ones and then put the one big guy on top of them, just to reduce the amount of extensions I need to do. So let's see. There's also a 200 at 150. I got a 220 at 200. We need a 10 at 150 and a 100 150. Those I might not have ordered. Probably already have them, but let's take a look. 100 at 200 volts. Okay, so this will be, yep, that's one of them. Another one of them. These are all high temperature, long life, high ripple current caps. So we need one more, 10, 200. I remember now, yeah, I did order up all fresh caps. Makes it easier for me to invoice the customer, plus guaranteed we all have fresh, high-grade caps. Got a couple CS series, a CY series, and this is a United Chemcon, I think, NL series, something like that. So 3 of them are skinny. Then we got the big old fat guy, the 300. So if it was just these 3, we could fit them all on the bottom. Well, here, do it like this. They would fit in there, no problem. But not all 4, I don't think. I don't know if I can hold all 4 at once, but even, let's see, will these 3 fit? Ooh, hey, you know what? I think I'm being pessimistic. Oh, look at that. They just fit. They just fit. So we'll see how it goes. I don't want to. If I have to drill a lot of holes in awkward places, I might still stack it. But at least physically they will arrange it. So we have these 4 lugs. They're coming through, and the stumps of them stick out here. Now, why don't I leave them come up? Because these are steel, tinned steel. Everything inside here is aluminum. And the way they attach these two, it's like they spot weld or something, the aluminum to the steel. You can't solder to aluminum, not easily, unless you get special solder equipment or whatever. I want to deal with that. So the standard way of doing this is to drill 4 holes near these lugs, and you run these leads through and you wrap them around, you solder them on this side. Oh yeah, now I remember how these go. In fact, you can see it here. So the aluminum actually comes through, and these stakes have fingers that come around and wrap around. So they're actually not even soldered or welded. The aluminum from the capacitor jelly roll inside is just crimped to each of these. So there was nothing inside here that I could have soldered to. I need to run them through, wrap them around near the base, and then solder. Now this is a circuit board mount, it's not lugs, and it stands a bit up off the board. They actually have a spacer on it. So if I wrap my wires around the fat part of the base here, that'll be no problem. But of course, they can't touch each other, and we need to leave some pretty decent clearance. It's not too high volts, a couple hundred volts is the highest voltage in here. And even when this starts running, we're at what, 150? So the electricity is not going to like jump a 1/4 inch arc or anything like that. And we want to make sure we clean all this off because we don't want any possible conduction paths through this. Use some alcohol and clean that off. But so my job now is to plan, how do I want to arrange these, and how do I want to drill my holes. Now the negatives all go together. So Ideally, we face all the negatives towards the inside, connect them all together, and we drill a hole down the middle. Or run a lead out towards the edge. And then when we're done, we're going to put this back down. Now, I was thinking, oh, like, how are we going to secure it? This, I can't even get it back in. We're going to heat this up and we're going to shove this in. I think that's going to be plenty good enough for structural integrity that this isn't going to fall off. But if one was concerned, you know, like I don't want to push it all the way because I got to get it back out. But I think that's going to hold pretty well. But you could run, of course, a bead of some adhesive, especially because it's whatever I do, it's going to be covered by this. I forget exactly how this goes. I think it goes like that. But I could run a bead of like 2-part epoxy around the inside before I push this in or something like that. Alright, so it's an interesting technique. Heating it up and getting the insides out is not the most fun. But yeah, filing it down, I mean, that leaves a really clean seam, and you can see when we put this back inside, it's going to look like nothing ever happened to it. So, yeah, alright. Still don't like doing this, but if I have to do it, I like this technique. Now you might be wondering, hey, what about that steel ring? Well, yeah, it's a good point. I kind of forgot about it myself. Potentially we could leave it out, in which case there'd be less support for the can. It would just be these 4. So if I put it in, remember, well, we sanded it. We filed off that aluminum, so there's nothing to hold this down. You got me thinking, I think the guy who did this that I originally saw modified this. So imagine if we could get this enlarged a bit, extend it down further, we could roll over the edge. Or this is actually made of 3 phenolic wafers. If we popped one out, this wouldn't be as thick, and we could again roll over the edge, but then this would be a little less sturdy. No, I don't have a reaming tool. I forget what they're called, but for automotive, you like it for expanding pipe, a pipe expander. So it's something you insert. I think it has 4 pieces to it, and you crank on it, and they start spreading out, and it would enlarge this. And then we could put that down further. For that matter, if we were doing that, we could have just cut this off to begin with, and then enlarged another section. It would be shorter overall, but it's plenty long enough as it is. So I got to ponder quite how I want to deal with that. I think if I just tried to glue this down, it wouldn't be very secure and it would fall off. I don't particularly want to invest in a pipe expander if I don't have to, though. But let's focus on the one thing we do know, which is mounting these caps. Now there are little symbols next to each of these lugs. We have no symbol, we have half round, we have a square, we have a triangle. Those correspond to the legend on the side here. We need to get those right. The largest one goes to the half moon semicircle over on that side. So, like so. To me, the really annoying part about that is if we didn't care about supporting this AV input, we could just mount these 4 caps to the board and be done with it. But I'll try to do my best to restuff this and make it stable. Alright, that wasn't too bad. Got all 4 caps seated, wired up to these 4 lugs, and added a ground wire, and it does fit inside the can. And, you know, I'm thinking this is sturdy enough as it is. For one thing, this is a lot lighter than the original was. So it seems to me that these 4 lugs should be enough to support it. But I'll ponder that for a bit. Meanwhile, I'll wrap up the rest of the work on this board. So I traced out some of the modifications a little bit. This is the sound input. This charred area, this is your audio output tube. And that, it looks like they bodged in a 1 meg resistor to ground to the grid of that tube to give it some biasing. Stick it up here on the schematic. So that is pin 3. That's where they're feeding in the audio. I imagine they cut this trace. So that would be the 17 BF11 combination. Well, it says audio detector, but I'm thinking it's more like a preamp and then power amp output. So yeah, again, it's funny how much of this is not needed. We don't need that. We don't need that. We don't need that. So this other wire has got to be the video. So pin 7 on the 11 BQ11. BQ11 pin 7, that's a ground. That can't be right. Oh yeah, sorry, that is ground. So maybe that's input ground, and maybe this is where the video is coming in. Pin 11 on the 15 BD11. Oh yeah, sure, right there. Test point 3. So yeah, we don't need this. So theoretically, I could remove some of these tubes, and to complete the filament continuity change, throw in a lump power resistor to substitute for those. Probably adding a thermistor would be a good idea too, to give it a bit of a slow start. However, if we remove these circuits, there's going to be less drain on B+, and it's going to throw some of these voltages off a bit. Plus, I don't want to go tinkering with something, so I guess I'll leave all that other stuff just as is. I think I'm just about done replacing caps. There's one more right there I want to get, but not right now because I was taking a look at the Flyback, and it is miserable. Whatever that outer donut is, it shrank and cracked. I don't think it's wax. I think it's some type of really silicone maybe or something like that. It especially shrunk badly right where the business end comes out. I threw in some Corona dope to stabilize things, and I'm going to wait for that to set up before I do any more work on this. I think I may do a little searching to see if I can get a replacement Flyback too. It was some green corrosion, or still is some green corrosion down in there, and this metal frame that goes around it really blocks access to things, so even patching it up is a little tricky, and it's not something you can take off easily because it's held on by this wire that goes around the powdered iron core. Pretty simple Flyback too. It's the auto former type where there is no primary and secondary, it's just all one. So we get our juice going in there, our drives, our output of the plate of the horizontal output tube is going in here. Got a bunch of windings here, and that's going to the high voltage rectifier. That's where it's all cracked and damaged looking. And they got various taps for the yoke, the damper, and at the bottom we get our boost voltage. Otherwise, I can spot check all those resistors. And there's some rectifiers I want to replace, like this guy I noted earlier. Someone tried to double check, is that even supposed to be like that? Is it supposed to be there? Because it doesn't look very nice. Now I do have parts locator. So that would be down in this corner. So there's supposed to be a 1 amp slow blow fuse down there, apparently. Yeah, that's the top view. I got it orientated correctly there. A little baby audio output transformer. So, what's supposed to be down in that area? Supposed to be a fusistor in here too. Considering with the trauma that this thing's been through, I want to make sure we have good power resistors, fusible resistors, slow blew, fuse, whatever protection this thing is supposed to have. I want to make sure it's still there and somebody just didn't short it out. Alright, so it's opposite the flyback. I do show a couple diodes there. I think that's the area we're looking at, but I only see one. Okay, that's our main power supply stuff here, and although they show 2 diodes on the parts placement diagram, I believe there is only supposed to be 1 diode, and it is this guy, Y401, and that is supposed to be a fusible resistor. Looks like just a regular straight up power resistor to me. Correct value. There's a part number on it, so it looks kind of original, but that's not what a fusible resistor typically looks like. And I can't believe that that's how the diode was originally mounted. So I'm thinking that stuff might be replacements. So yeah, we're looking at that. That's fusistor R401 and B plus rectifier Y401. So they show it going between 2 pads. So yeah, I don't think that's right. Anyways, I'll poke around in that area, but tomorrow I'll let this set up overnight, stabilize. I did check it for continuity. We do have, around 450 ohms between these 2 points. I measured between pin 5 on this tube and the cap going to the rectifier. I lightly soldered in those replacement electrolytics. If and when I get this thing working, I'll pop that back out and crimp over the can. And meanwhile, the Corona dope has set up on the flyback. This is far more secure than it was. Time will tell how well this works and will it hold up. Now, I did find the part number for it. And I found the Thord Arson replacement number. It's Fly 26 something. I think I've written down upstairs. I'll let you know what it is in a moment. I already looked around the obvious places. eBay, Early Television Museum sells replacement flybacks as well. They don't have them. I could try Moyer's Electronics, assuming they even still deal with this kind of thing. Otherwise, I'll ask the community. I suspect it's going to be tough to find, just like a replacement picture tube is tough to find. It may seem counterintuitive, but actually parts for older sets like this, 1949 Zenith behind it, these are easier to find replacement parts for the most part, than it is for something from the 70s. Why? I suspect it's because these sets got repaired. If you plunked down a small fortune to buy this set in 1949, and if a couple years later it broke, you would pay to get it fixed. So there was a thriving aftermarket for parts suppliers. In fact, there were more than one. There was Merit, Thord Arson, Ram, and a couple others. You get into the 70s. Okay, this thing is still tubes. First all-transistor black and white TV came out in like 1961, so a decade later, and this is still all tubes. Tubes were rapidly on their way out. If this set died, say in 1980, I can't imagine anybody forking out the money to bring this to a repair shop and get the flyback replaced or the picture tube replaced. They'd just toss it and buy a new modern solid-state TV. So, yeah, Thord Arson did make a replacement for this, and by the time you get into the 70s, they might have been the only one left standing. I think they merged with Merit, maybe some of the others. So yeah, they made one. I don't know how many were made. I don't know how many got used. I don't know how many might still be floating around out there, but my quick searches came up with nothing. So we'll do what we can to baby this and hopefully bring it back to life. Again, when this set gets running, I'll go over and seal up. There's another crack over here and go over that better. But I don't want to put a ton of time and effort into some of these components if this whole thing just, bad things have happened to this. And I'm still not all that confident that it's going to work. Other than the owner said it did work for a while, but man, looking at this thing, I find it a little hard to believe, but that's what he says.